Okay. Computers have always been embedded into all sorts of everyday items, from planes to TVs, in-house entertainment centers, and toasters. These are usually called embedded computers or embedded systems and actually account for more than 90% of all the world's manufactured processors. Nowadays, many embedded systems interact with the physical environment surrounding us using a variety of sensors or actuators. In our project, we're using a heart sensor in an embedded system for the purpose of helping people check their heartbeat rate and contact a specified person in case the heartbeat rate sensed is out of a specified range. So, a lot of disabled, elderly, or severely ill patients may not be able to call someone for help when they are tired. And they also might not be able to go to the hospital to check their heart rate. Therefore, we decided to make this device in order for patients to contact their emergency contact if their heart rate exceeded a certain limit, without needing to understand a lot about technology, and also they don't need to do any physical effort or movement. Okay, so this project is made to help the disabled, elderly, or patients with severe conditions. The heart sensor should be connected to the patient's finger, and the sensor is also connected to the Arduino board. The Arduino board is connected to the Bluetooth shield, and if the heart rate exceeded a certain limit, the Bluetooth shield should send signals to the patient's mobile to call the emergency number saved on the mobile application. So, the process works as follows. First, we worked on the Arduino and the heart rate sensor. We connected them both together and we made sure that the Arduino responds to the signals sent by the heart sensor. Afterwards, we linked the code to an interface that allows us to read the heart rate on the computer screen. And then came the time to connect the heart sensor and the Arduino to the mobile. And seems like the Bluetooth is the easiest way because it only requires the patient to open a Bluetooth connection and pair with the device, which is independent of any mobile internet connection which may not be understood by elderly or the disabled. We then had to test the Bluetooth shield with the Arduino as well. We used the code that was attached to the Bluetooth shield to set up the attributes of the shield, such as the name, password, role, and the baud rate. In order to test this, we worked on Android phones because it's easier to work on their applications, so we use an application that connects with the Arduino by Bluetooth and can send signals. The application calls a saved mobile number if the heart rate exceeds or is lower than a certain number. We also made sure that this is working by setting the shield as master, and we connected it with a Bluetooth SPP enabled device through an Android application that we developed. It displayed anything sent through the serial monitor. Okay, now we'll start by setting up the Bluetooth shield. In the project, Arduino uses serial communication to connect to the Bluetooth shield. Arduino's digital pins D0 to D7 can be chosen as software universal asynchronous receiver transmitter to communicate with Bluetooth shield. However, in our case, we're using the Mega library that does not support these pins, so jumper pins 10 and 11 were used for D out and D in to resolve this issue. Bluetooth Shield has default baud rate 38,400 and 8 bits for data representation. To set up the Bluetooth Shield, first we need to do the software connections. We install and choose the Bluetooth application on the Android phone. It's the Bluetooth B application, and we power on the module into command state. Second, we need to connect the hardware. We input high level to pin 11 and supply power to the module. The module will then enter to the order response work mode. In our case, we use the switch at the H side. That means input high level to the Bluetooth pin 34. Then the module will enter to the AT mode. Now we're in the AT mode for that we can send commands from the serial port to control and set the Bluetooth module. First of all, we send AT and wait for the OK response. Second, AT plus role equal 1 means that we need it as a master role. The C mode means that we connect to the module to any address, any Bluetooth address. And the AT plus name, here we specify whatever name we need for the Bluetooth shield. The AT password also, we specify the password we need to use. The init is where we initialize the SPP profile library, and the INQM is where we inquire the Bluetooth. The first parameter used is the RSSI signal intensity indication. The second parameter used, which is 9 in our case, means that we should stop inquiring if more than 9 Bluetooth devices respond. And the third parameter, which is 48, means that we limit the time for inquiring is 48 times 1.28, which is 61 seconds. Here, all the devices are displayed. We pair with the device we want, and then link. And that's it. Now the Bluetooth device and they are connected.
So as we've explained in the introduction, this project wants to measure the heart rate. So therefore we decided to use a pulse rate sensor. A pulse sensor is well-designed plug-and-play heart rate sensor for Arduino. It can be used for students, artists, athlete makers, and gamers and mobile developers who want to easily incorporate live heart rate data into their projects. As we can see here, this is how we wanted to put the hardware connections in the Arduino board. Firstly, we wanted to make sure that the heart rate sensor is working. Therefore, we connected it to the Arduino in this form. The red wire is connected to the 3 to 5 voltage. The black wire is connected to the ground. The purple is connected to the signal. Connections as seen here, the voltage red, ground black, and analog is for pin 0, is for the purple wire, as we can see. Then we decided to connect it to the computer. As we can see here, as soon as the Arduino and the sensors are connected together and then we connect it to the computer as a power source, we can see that their LEDs are lit up. We can see here that the LED of the Arduino Mega board, and we can see here the LED in the sensor itself. Now we're going to take a look at the code that we decided to work on so that we can see the sensor working with the Arduino in a form of an interface. As we can see here in the code, we can see first that we are initializing the variables that we're going to use within the code. For example, we're using the variable inSensor so that we can retrieve the data from the Arduino from the pulse sensor. Here is the time between the heart rate from the Arduino. For example, BPM is the heart rate value from the Arduino. Here are some arrays that we store in it, the waveform of the data retrieved before scaling and after scale. Also, here we put some values that we're going to use afterwards. For example, for the interface, the color. We're going to use the color and we're going to call it eggshell, and we're going to use an RGB color code so that we know the color that we want. Afterwards, as we can see here, is the setting up of the interface itself, how we're going to put it in the center, and we're going to call it have a certain font, and the frame is going to have a certain size. Afterwards, we're going to have the loop that is going to tell us our window and where is our bottom in the graph. Afterwards, we're going to go to the Arduino board itself and we're going to connect with it. In order to know the connection or our serial list, we have to print all the serial list that we have, and then we're going to choose the number that we want. Also, we're going to create a new port with a serial, and this serial should be in the list. And we're going to choose the array at the first part of the array, and we're going to have this baud rate in order for it to work. Then we're going to draw our interface. First we draw the background, and then we go to fill it with the color that we have already initialized at the beginning, and then we have the rectangle and the pulse window and the window height. Then we prepare for drawing itself. We had an array that was initialized at the beginning, and then we start drawing the data points, and afterwards we're going to have the light, and we're going to have draw lines so that it would fill the graph, as we can see here. Afterwards, we're going to smooth the graph, and as we can see here, we're going to fill the text to print the data with the variable values. This was a quick overview to the code, and then we're going to go back again to our slideshow. Here are some slides, two important parts of the code. And at the end, when we run the code, we're going to have this interface telling us the heart rate and the graph that is simulating the heart rate that we're going to have. Thank you.
So carrying on after the sensors part, now it comes to connecting the Bluetooth shield and the sensor together. And this is done by putting the sensor connections exactly just how it was on the Arduino board, but instead it would be just connected through the shield, same ports and same pins and everything. Now as for the code, the integration part was about, I took the sensors code, the normal sensors code with the interrupt file, but I didn't change anything in the interrupt file, and I defined also the pins 10 and 11 because we're using the mega board. And then I just, all I'm gonna use, I'll use only the BPM, which this is the variable that holds the beat coming from the interrupt after all the calculations are done. And then we go to the setup, we set up the pins and everything and the blink LEDs, and then we call the interrupt setup, call this interrupt setup, just the normal code. But the difference is that we're gonna set up a new serial connection, which we call it the Bluetooth serial, and we call this method. This method sets up the Bluetooth connection. However, the Bluetooth shield was already set up and initialized with the code in the first part of this tutorial that Nihal explained, and this shield is set up as slave. Now it is running in slave mode, and the name was set to BT shield, and the password was set to 4 zeros. So now all we gotta do is just begin the serial with this baud rate, which is the default baud rate, and then send the test command. It's not really necessary, but we just send it, and then we initialize the SPP profile, and then we inquire the Bluetooth devices around. And this delay helps us in connecting to the devices and doesn't let the shield crash or the application crash. Then we do the flush. So we go back to here, and then after this finishes, the serial itself begin, which will be with this baud rate that the sensor communicates with. Then we go into the loop. Here the loop, it checks if there is any data sent from the remote Bluetooth shield and saves it in this char, and it prints it in the serial. And here if the opposite, if there's any data sent from the local terminal serial terminal. So we here just print on the serial the BPM, because the BPM already holds the value. So we just send the BPM. We know these are commented, they are not used, and this is used for the blinking LED to blink according to the heart rate when it finds a heartbeat, and then it calls this method with this fade rate. This is for the code, and this was the integration part. Now as for the now we'll cover the Android part, which is Yusuf's part actually. We basically took an application called BT EP, Bluetooth EP, and we based the application on it. It was just a Bluetooth SPP terminal that used to communicate any Android device with the Shield, but we modified it to work on our project and to display directly the heartbeat with an easy interface to the user. So what we need to do, first of all, we check if the device is paired or not, because if it is already paired, the sequence in the Bluetooth Shield enables it to be paired from inside the application. So we'll disable now it's unpaired. We'll disable the Bluetooth because it can be opened from inside the application. This is the application. This is the application. Now, the first button enables the Bluetooth. It just requested it needs my permission to enable the Bluetooth and makes it visible for 120 seconds. And then here we enter the mobile number, the emergency mobile number that we will contact if anything goes wrong, or if the heart rate is maximum, goes higher than the maximum heart rate that we're gonna set, or lower than the minimum heart rate that we're also gonna set. But we're gonna set it to a little bit higher because our sensor isn't really that accurate, so it displayed wrong readings. So we'll just set it to 236, and if the heart rate actually exceeds the 236, it will automatically dial this number, which will be this phone. This is the number. So we click next, and then we put the minimum heart rate. We'll just put it 0 in order just to make sure nothing goes wrong. And then after it's done, we click on get heart rate. We just make sure the connection here is okay. Now everything is connected and the LED 1 is blinking. This means that there is a connection and the Bluetooth is working. So now, after we click on get heart rate, it will search for the devices around. We already called the Bluetooth Shield BT Shield. This is it. So we're gonna press on it, and then we're gonna click restart from here, reset. We're gonna enter the pin we already defined, which was 4 zeros. Okay, again, we'll do it again. I was late in the pairing process, so it said unable to pair. I think now it is already paired. Okay, we'll pair again. Now, and then we'll click reset. Now they are paired. And now you can see the heart rate appearing in the application. So I just need to hide the keyboard. Yes, there you go. This is the reading. If the reading reaches 236, it will automatically dial this phone. Dial the number and call this phone. So I'll just put my finger here. Accidentally clicked back. Okay, we'll do the connection again. Get heart rate. Oh, we set the mobile number again. 0, and then we click get heart rate. And when you connect to the BT shield and click reset on the board. And now we can see LED 2 is constantly lit and LED 1 keeps blinking. Now we are receiving data. So now I'll put my finger here and try to put some pressure on it to raise the heartbeat. Once it reaches 237, the call will be initiated and this phone will ring, as you can see. And when I click end call, it will go back to the application. If the pulse is still high, it will dial again. Apparently it was high, so I'll end the call. Now it is actually displaying a normal heartbeat. Okay. And there you go. That's it. This is how you make an Arduino sensor, pulse rate sensor board, and set it up and connect it to Android device and display the heart rate and call a phone number, an emergency phone number. Thank you.